Hello, today we talk about parallel lines and transversals. Here are your essential questions. So when we have a diagram that looks like this, with a pair of lines that may or may not be parallel, and a third line that intersects them, that third line is called a transversal, and 8 angles will be formed. And we need to know the names of those pairs of angles. And so corresponding angles, such as angles 1 and 2 shown, lie on the same side of the transversal and the same side of the other two lines. Alternate interior angles are inside those two lines and on alternating sides of the transversal. One is high, one is low, one's on the left, one's on the right. Alternate exterior angles are on the outside of the two lines, and they're on alternating sides of the transversal. And same side interior angles are inside the two lines and on the same side as the transversal. So there is a postulate that we're going to assume is true. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. And from there we could prove this one. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. Also, alternate exterior angles will be congruent if the lines are parallel. And finally, if the lines are parallel, same side interior angles, careful, will be supplementary. That is, they will add together to equal 180 degrees. Here's our first application problem. We have a diagram where two lines are given as parallel and we are asked to find the value of B. First, notice that line N is a transversal, that the two alternate interior angles are marked as 36 degrees and 5B minus 45. So we can set them equal because of the alternate interior angles theorem. And we can just use algebra to solve for B. And so B is 16.2. So now, how do we prove that lines are parallel if we are given information about the angles? Well, we have the converse of the corresponding angles postulate, which says, if a pair of corresponding angles are congruent, then the lines are parallel. So here we have a pair of lines where to prove they're parallel. First, let's note that line L is the transversal, that angles 1 and 2 by definition are called corresponding angles. We can see in the diagram they're congruent. Therefore, by the converse of the corresponding angles postulate, we know that lines M and N are parallel. Okay, here's our converse of the alternate interior angles theorem. If in a diagram a pair of alternate interior angles are congruent, then the lines are parallel. So we'll apply this. We're to prove in this diagram that J and K, those two lines, are parallel. Notice that line L is a transversal. Angles 1 and 2 are adjacent angles. They are actually a linear pair, therefore they're supplementary. So since they're supplementary, we know the measure of angle 2 is 57 degrees. And now we know that 2 and 3, which are alternate interior angles, are congruent. Therefore, lines J and K are parallel by the converse of the alternate interior angles theorem. So here's another theorem. This one's called the converse of the alternate exterior angles theorem. Now let's apply this theorem, okay? We are to prove that lines P and Q in this diagram are parallel, and we are given, of course, that angles 4 and 6 are congruent. So let's name the alternate exterior angles. They are 1 and 7, check the diagram, and 4 and 6. Since 4 and 6 are given as congruent, we now know by the converse of the alternate exterior angles theorem that lines P and Q are parallel. Okay, one final theorem to look at. Converse of the same side interior angles theorem. So if we know in the diagram that angles 1 and 2 are supplementary, then lines M and N are parallel. Let's apply this theorem. Okay, so what do we know in this diagram? We are to prove that lines S and T are parallel. We're given that angle 3 and angle 5 are congruent. All right, so we are given the following information. We know that the same side interior angles are 2 and 5 and 3 and 8. Double check in the diagram that you agree. We know that angle 3 is congruent to angle 5. But we also know that angle 3 and angle 2 are supplementary. Since angle 3 and angle 2 are supplementary, and since angle 3 is congruent to angle 5, we can substitute angle 5 for angle 3, and we can now say that angle 5 and angle 2 are supplementary. So because of that, by the converse of the same side interior angles theorem, we know that the lines are parallel. Okay, so let's summarize what we've been talking about. Make sure that you can identify corresponding angles. Check the diagram, make sure you're in agreement. Make sure you can identify alternate interior and alternate exterior angles. And finally, where are the same side interior angles? Okay, so that's just strictly identifying special pairs of angles. Now, if the lines are parallel, what do we know? Well, we know that those angles are going to be congruent. Corresponding angles, alternate interior, and alternate exterior. And what do we know about same side interior angles? They're supplementary. Finally, how do we prove that lines are parallel if we're given information about angles? If we know that corresponding angles are congruent, then the lines are parallel. Same thing with alternate interior and alternate exterior angles. And finally, if we know that same side interior angles are supplementary, then the lines are parallel.